Hi everybody. This is the IB probability and set theory package. This is example 4 in the section that's primarily about set theory. Okay. Question says 50 married men were asked whether they gave their wife flowers or chocolates for their last birthday. The results were 31 gave chocolates, 12 gave flowers, 5 gave both chocolate and flowers. Now, if one of the married men was chosen at random, determine the probability that he gave his wife, and then we got to work through these 4 questions here. Now, this question does not specifically state that we should be using a Venn diagram. However, Venn diagram would be a perfect tool to use here. So we'll make this our flower circle. We'll make this our chocolate circle. Okay? We know that there are 50 men in this little sample space here. 31 gave chocolates and 12 gave flowers, but 5 gave both. Okay, so we got to start with both here, because when we're told that 31 gave chocolates, well, I don't know how that's split. In chocolates, there's two separate sections here. Now, I don't know how it's split up until I identify the middle part here. Then I know that means, there must have been 26 who gave just chocolates. Okay, if there's 5 who gave both, and we know that there's 12 gave flowers, that means there was 7 that gave just flowers. And now take a quick look at this. This is 7 plus, if you go 7 plus 5 is 12, plus 28, sorry, plus 26 is going to be 38. Okay, so I'm just going to actually double check this on my calculator here, just because now I screwed up that calculation. I want to make sure that I get this right here. If we take the total 50 here and subtract the 26 from it, and then subtract 7 and subtract 5, we get 12 left over. Okay? Now I'm just going to double check that again. No, that's right. That's right. So there we go. So there's 12 out here. So now it makes this a lot easier to answer this question. How many gave chocolate or flowers? Now, or in this particular case could mean one, the other, or both. It doesn't necessarily have to mean just one or the other, okay, in an exclusive sense. We're going to include it here, and we always do. So 7 plus 5 is 12, plus 26 is 38. That means there's 38 out of 50 that gave chocolate or flowers. Now that can be simplified a little bit here. I can divide by 2. It doesn't do much here. I get 19 out of 25. Okay, how about they gave chocolates but not flowers? Okay, so that's the chocolate section right here. But this little group of 5 here also gave flowers. So when we say chocolates but not flowers, it's this little bit that we're referring to right here. So that will be 26 out of 50. And again, I can simplify that just a little bit by dividing by 2. Okay. How about they gave neither chocolates nor flowers? Whoop. These are the guys that had to come up with something a little bit more creative. Well, that's that group of 12 right here that doesn't fit in either one of those groups. And again, if we simplify that by dividing by 2, we'll get 6 out of 25. Now, flowers, if it is known that he did not give her chocolates. Okay, flowers, if it is known that he did not give her chocolates. So in other words, what we're doing here is we are covering up the chocolate section. Okay, we don't care. We're not worried about those people that gave chocolates at all. Just how many people are left over? Well, I've got 7 here and I got 12 here for a total of 19. So when we look at the people who didn't give chocolates, okay, that's a group of 19 people. So from that group, what's the probability that they did give flowers? Well, there were 7 of them there. So that is 7 out of 19. Okay, so this is a problem here where we are reducing the sample space that we are considering. Okay, we're not looking at that overall group of 50. We're looking at that subset. Okay, getting rid of the people that did the chocolates.